Hi, Graham Roberts. Welcome to another tutorial on occurrences, really, finding the number of occurrences. We're looking at this for two reasons. One, it's part of a phase test that you have to take to be able to answer this kind of question, but also to see how we can find patterns in mathematics, and I did a little tutorial on that before. Now, this is a C# program which is going to show us how this could actually be done in a programming environment. Now, we wanted to get a formula, a rubric, and we did achieve one. So we could, knowing the maximum value of the balls and the number of picks and replacements, find what the answer should be to the number of different totals found. In this case it should be 26, and we saw that from a table which you can see above. We did this by investigation, and the formula we said was P times B less P plus 1. Now in that case it would be 6 times 5, which is 30, less 5, which is 25, plus 1, which is 26. But this program does not do that. This program, as you can see, picks and removes balls. It did it 16,659 times, and by that number of picks it had in fact found all the possible different totals that there were. Now, that tells you something, I think, about probability questions. That when you get into the real world, in actual fact, the occurrence or chance is much is not quite what you think. When you're in low numbers, it quickly becomes much more unlikely than you think, as it were. In other words, you don't get all of these different results when you do this. If you had balls in a box, you'd have to play with the balls in the box for a very long time before you actually came up with all the different possibilities of the solution space. But in programming we have the advantage of what we call the brute force approach to this is what this is, to actually discover what actually happens in the real world. But still, we would try to find a formula, and we would prefer to find a formula. Right, so what are the actual totals that were found? We found a 5, a 6, a 7, and so on. And notice that the pattern is that they all go up by an increment of 1 to 30. There is no 4, no 3, no 2, no 1. And indeed, that means that 4 possible totals are missing. And that's why we took away 4. Or rather, we added 5, the number of picks, and took 1 away from that. I beg your pardon, we took away the number of picks and added 1. Okay, well, let's have a look at experiment here and see what happens when we actually apply this model. Well, we said what would happen with 6. And if you remember, we predicted what it would be. Now if we do that, what would it be? You might like to stop the recording for a moment, pause it, and see if you can remember or work it out. Right, I'm going to say go, and it's found that after picking and removing balls 158,616 times, it discovered them all, and the number of different totals found was 31, which is what hopefully you found it should be, and those totals are from 6 through to 36. The product of 6 by 6 is of course 36, and the lowest number we could get is 6 times 1, which is 6, so that's in that list, but or set, and the numbers 1 to 5 are not, because the minimum number you can get is 6. Sorry, the minimum total you can get is 6. Right, let's play with this a bit more. What about if the number of picks was not 6, but 7. Would you like to pause the tape recording and see if you can predict what the answer should be? And the answer we get is 36. This is the answer to the universe and everything, if you know your literature. Anyway, 6 sevens, what's that? So let's multiply those out. 6 times 7, right, 42. And we've got to take away the number of pigs, so we take away 7, and we get 35, but we've got to add 1, and we get 36, which is what we found. What if the number of pigs was 8? You might like to pause and have a prediction. And there we have the answer. This time is 41, and we can see the numbers are all from 8 to 48. If we change the number of the highest value that can be, we add, for example, 8 as the highest ball, 1 is the lowest ball, and we have 8 pigs and replacements. What do you make it now? Try to apply the rubric. Well, I'm going to say 8 times 8 minus 8 plus 1. So the rubric tells me there should be 57 different totals possible. Let's check it and see. It's going to take a while to find this. It's found it now. And it does find 57, and they're from 8 through to what should be 64, and I'll just pull that over so you can see it. 64. Before we leave this, what do you reckon to this? Let's say we had 4 was the maximum value on the ball that you could have, and we put it up and down, let's say 3 times. What do you predict the answer to be? And can you predict what the actual values will be now? Yes, it's 10. And the values will be from 3 to 12. 1 and 2 cannot be seen because the minimum value that you can get is 3 times 1. Well, hopefully what this little exercise has shown is that finding patterns, whether by desk checking as it were, or by writing a program and using a brute force approach, either way you can end up with a rubric and a formula. This program does not use the formula. If I had the formula, I could actually put it into a spreadsheet and thus answer the question that was set for any number of balls, values, number of picks. So let's do that. Here we have Microsoft Excel, and I've got B and P, and I've got hash. Well, we want to find what the result would be. So we say this cell times this cell minus the pick cell plus 1. That was the formula, that was the rubric. Now obviously it says 1 there at the moment, but let's put some numbers in here. This is 1 because we added 1 to these two. There's the product of 0 equals 0. So if we put in there 5 for a number of 6 for the number, the highest number of the ball, and 5 for the number of picks, we get 26, which is what we predicted. What would it be if it was 10 was the highest number on the ball and the number of picks we did was 10? What would that be? It'd be 91, because it would be 100 less 10 1. So this is our formula, our rubric, and so in that very simple expression we have got a calculator for the problem that we set earlier, like this. We go from the mathematics, which is the pattern finding, we find a pattern, we find a formula, we can then do computations and arithmetic, and we can put that into a program. That's the point of mathematics for IT practitioners. And the investigation is quite a bit of fun too.